In this video, I will introduce the split apply combine framework. So this is basically a framework that can be useful in many different types of data analysis. What it essentially allows you to do is to apply a given function or method on subsets of your data. So for instance, if you want to compute a mean individual income, you can do this with the split apply combine framework. So I'm going more into detail with that in a minute. So what is the split apply combine framework more formally? So as the name suggests, it's a procedure to first split a data frame into subsets of data. So that could, for instance, be subsets based on a personal identifier in your data frame. Then it allows you to apply certain functions or methods. So that could, for instance, be sorting, computing a mean, or computing a variance or something, a function that you've written up yourself on each of these chunks of data, and then combine it into a new data frame. So consider the example of computing a mean individual income. Then we would split a data frame into subsets of data based on this personal identifier, compute the mean of income within each chunk of data associated with each unique individual, and then we will combine it into a new data frame that only has one row per individual, and this row contains the mean individual income. So in order to better understand what's going on, consider the following illustration here. So suppose that we have a data frame that originally looks like the following here. So we have two columns, X and Y. So X could, for instance, be a personal identifier, and Y could, for instance, be a measure of income. So we see that we have three unique values for X, so these could be three persons in our data frame. Now we want to split our data frame based on these values. So that's what we get here. Because we have three different unique values, we get three sub-data frames. And now we apply the mean method on the Y's in each of these sub-data frames, and we get the following. And we can then combine what we get back into a new data frame that only has one observation per individual, or one observation per value of X, which was the value that we split our data frame on. Okay, so let's now use the split apply combine framework in Pandas. So a powerful tool in data frames is the group by method. So this method is what splits our data frame into different sub-data frames, and is therefore essential for this framework. So consider the following example. So here we want to compute the mean total bill by sex in the TIPS data frame that we got from the Seaborn package. So how do we do this? So it's actually quite simple. We can do this with one line of code. So first I specify that I want to work on the TIPS data frame. Then I specify that I want to split our data frame by the variable sex. So because there are only two values for sex in our TIPS data frame, we get two different sub-data frames. Then I specify that I want to apply a method or a function on total bill. And then finally I specify that I want to compute a mean. And by simply writing this one line of code, I get the following output. So here I just get the mean total bill by sex and nothing else. Okay, so in order to understand what's really going on, we need to understand what group by does here. So as I mentioned, group by creates a collection of sub-data frames that we can process individually. So consider again the same example, but we're really going into depth with what's going on under the hood. So first we create a dictionary called results. This is just empty to begin with. They were using that a group by object allows iteration, and it creates a sequence of two tuples that contain both the name of a data frame and the data frame itself. So we're using that in a loop here, in a for loop. So in this case, I iterate over the two different sub-data frames that's created with this sex variable, and then I store first the key, which is the value, different values in the sex variable, and then I compute the mean within each of these sub-data frames, and then I store it in this results dictionary. Then finally I use the Pandas series constructor in order to create a pandas series based on these results here, based on this computation. And what I get out of it is exactly this. So this is exactly what I had before, right? So you can think of it as this is really what's going on when we use this split, apply, combine framework in pandas. So group by is essential here. Okay, so at this point, it's natural to ask, can other methods be applied as well? So we just saw that we can compute a mean within different groups. So can we also do other things? Fortunately, yes. So we can, for instance, compute a standard deviation. We can find minimum values and maximum values. It just works. We can also use this apply method and just insert our own homemade function, and that will work as well. So this approach is actually quite flexible, and you can do many things with it. Okay, so now we may ask, does this group by work for multiple variables, and can we use different can we also use multiple methods or functions? So fortunately, yes. So consider this following slightly more advanced example here. So in this case, I want to not only split my data set on sex, but also time. And given that time also can take 2 values in this data frame, we get 4 different groups, right? And then I want to make computations on both total bill and tip. And I want to make 3 different types of computations on the same time. And we can actually do these things with the same line of code as we did before. So now I'm creating a new data frame called combined. And then I want to specify that I want to make computations on the tips data frame. And then here I just write group by split variables. And instead of just inputting one variable, I input a list with multiple variable names. Then I input also a list here on the apply vars, a list with multiple variables names instead of just one variable name. And then here with this apply functions, I input a list with 3 different types of methods. Here the notation is slightly different, right? And then I get a new data frame out of it in this multi-index representation. You can see this multi-index representation here that now on top I have the variables that I made computations on, and then below I have the different types of computations that I made. And we have 4 different rows, and these represent the 4 different groups in my data frame. So finally, we may ask, how do we get our group by output into the original data frame? So as you can see here, we started out with a potentially long and large data frame, and then we ended up with only 4 rows here. So can we get these computations back onto our original data frame? Fortunately, we can. And you can do it in 2 different ways. So you can merge them back onto our original data frame. Here you want to be careful. You need to specify the join correctly, right? So you want to make some kind of an inner join, and you want to make a horizontal merge here, but you want to be careful that you do this correctly, as we talked about in the previous video. Another way of doing it is to use the transform method. And I'm going to illustrate how this works in this example here. So here I want to create a new column called mu6 on our tips data frame. So this new column should contain group-specific means of the total bill variable, and I want it directly back on my original data frame. So what I do is that I basically just do what I did before. I write tips to access the data frame, and then I group by my split variables. So that was sex and time, and then I make a computation on the total bill variable, and then I write dot transform mean. And by doing that, I'm able to get this mu6, this group-specific computation, back onto my original data frame immediately. And after having done this, I can just start again making individual specific computations. So I can, for instance, compute group-specific deviations. So that's basically just for each individual, taking the total bill and subtracting the mean groups, the group-specific mean on total bill, and seeing whether this given individual spends less or more than the associated group.